Hey guys, here are your Geo Notes for section 2.1. And let me start here with a mad gap. So here's your first mad gap. Pane, sills, sharp, inner. And here's your number stumper. 100 S in the USS. So here's your mad gap. Here's your number stumper. If you want to put those on my desk tomorrow, I'll draw a name. And we'll see how that goes. Here's my little comic for the day. I enjoy Foxtrot. He's pretty cool. So he's golfing here, and then he hits it, and he's a little afraid. And he looks, and he hears Radical 16, and his brother's like, Jason, or just yell 4, son. So he's a math guy, and he loves math. So instead of yelling 4, he yells Radical 16. All right, just a little comic for you. Here's our notes today are on parallel, perpendicular, and skew lines. So lines are parallel if they are always the same distance apart, called equidistant, which means they will never touch or never meet. So parallel lines, you can see them right here in this example, they don't ever touch. They will be equidistant apart no matter where you are on the lines. They're always the same distance apart. Those are called parallel lines. Always the same distance apart and never touching. You could also say they have the same slope. Same slope as well. If this is going a positive slope, this would have the same positive slope. They would be parallel lines. So same distance. You might even want to write somewhere in there same slope. That's another thing we also know about parallel lines if we're just brainstorming. Examples. Parallel lines also point in the same direction. So you can see they're going to point in the same direction. Take a look at the little website here. I'll come back to the notes in a second, but you can see the website. If you change any of these points, the other line completely follows it. It always follows it because it's parallel. They're always going to be in the same direction. So parallel lines never ever touch. No matter what happens, they'll never touch. And you can kind of see it as like streets here in Palmdale. Avenue S and Avenue R would never touch because they're running the same direction. They're both going east-west. Okay, so back to the notes. Parallel lines must be coplanar. They must also be coplanar. They're on the same plane. If two lines are said to be parallel, that means that they have to be on the same plane somewhere. Whether the plane's coming down, going across, they will be on the same plane if they're parallel. Skew lines, on the other hand, are not coplanar. They are on different planes and never intersect. So in other words, there's two different lines, parallel and skew, that will never touch. Parallel lines never touch, skew lines never touch. But the difference is parallel lines are on the same plane, skew lines are not on the same plane. Parallel lines go the same direction, skew lines go in totally different directions. They're on different planes. So that's the difference between parallel lines and skew lines. Parallel is going to see the same direction on the same plane. Skew lines, different directions, different planes, different everything, skew lines. You can always pause it if you need to. Perpendicular just means it makes a 90-degree angle. We talked about that in class when we were doing our perpendicular bisector. We talked about 90 degrees. So the red line is perpendicular to the blue line here. The red line is perpendicular because it makes a 90-degree angle. We always put that box for 90 degrees. The little box drawn in the corner means at right angles. So we didn't really need to also show that it was 90 degrees, but we just wanted to. So this is 90 degrees. They didn't have to write 90 because they had that box there. That box was enough. If you look at the website, and again I'll be back here, you can notice that no matter where you move, see, that's telling you it's not perpendicular. If you move it to where it's exactly 90 degrees, oh, there's perpendicular. I can move it back this way, oh, not perpendicular. Move it back to, oh, wait, oh, there it is, perpendicular. And you can move this and it will always stay, if you move these, they stay perpendicular. It doesn't have to be horizontal vertical to be perpendicular. This could be at this angle, this would be at this angle to make 90 degrees. But if I move it, oh, no, it's not perpendicular there. There it is right there. So 90-degree angles. would be perpendicular. Okay, let's see. Try to draw some for yourself. Okay, so let's look at it. This is kind of cool. Again, this is a different little page than what we were on a second ago. And it says draw line segments perpendicular to the blue one. So if I wanted to draw a segment like this, that's not perpendicular. But if you move it, oh, wait a second, I guess gotta try another. Okay, so if I move it like this and move, oh, green means perpendicular. Oh, there it is. Perpendicular line, that's perfect. You can try another, say put another one down here. So you could start like this and it's red, it's black, so that's not it, but you move it, oh, there it is. There's green, perpendicular. Oh, I let it go too early and it was not perpendicular. So it's just, letting you see that it doesn't have to be at a certain angle. So there's green, that's perpendicular. Those are going to make a perfect 90-degree angles right there. So you could play around with it just to show perpendicular lines on your own little website. All right, moving on. Again, if you need to pause it at any time, please do. Can you list a pair of skew lines? Okay, pause it, write down 2 skew lines, and turn it back on, and we'll see if you're right. All right, what I would put for skew lines, and there's lots of possibilities here, tons. If you happen to use AE, a skew line then would be way over here, maybe BC, going a different direction, and it's on a different plane. So that's going to be skew lines. AE and BC would be skew lines. You can't say AE and CG because those are parallel. They're going to be on a plane somewhere. If you use like AB, you could put DF. Those would be skew lines. So things like that. Now what about perpendicular? Perpendicular would be anywhere you see a right angle. So like DC and DF. FG and GC. Notice you're going to have a letter in common there. FG and GC. G was common. FE and EA. The E was common. The E is going to be where the 90-degree angle is. Perpendicular lines will have a common letter where the 90-degree angle is. And can you list a pair of parallel lines? Parallel would be like AE and DF, AB and DC. Those are going to be on the same plane. You can see that AB and DC are on this top plane right here. DF and CG are on this front plane. Those are called parallel lines. True or false? If 2 lines intersect to form a linear pair, we learned linear pairs last week, it means a pair of angles that make a line. Line is right here, line. If 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And that is a true statement. If you have a linear pair and this angle equals this angle, then they're perpendicular. They have to be both 90s. The only way that these two could be equal and add up to 180 is if they're both 90. So that would be a true statement, that first one. There's the picture to back it up. If 2 sides of 2 adjacent acute angles are perpendicular, then the angles are complementary. That is another true statement. If you've got this angle right here touching this angle right here, and they make 90-degree angles, those 2 angles have to be complementary. You might remember from last week, hopefully remember, that complementary means corner, which makes 90 degrees. So complementary angles add up to 90. If 2 lines are perpendicular, then they intersect to form 4 right angles. Another true statement. If you see 2 lines that are perpendicular, all 4 of those angles are right angles. You could put a box in all 4 of them. We don't usually ever put a box in all 4. We would usually just put a box in one of them just to show that they're perpendicular. So those are all 3 true statements. I would jot the little diagram down if you get a chance to put that so you know exactly why it's true. You can pause it if you need to do that. Here's the next page. Pairs of angles, very, very important. When parallel lines, you see parallel lines, get crossed by another line, which we call a transversal. Okay, let me show you what a transversal is over here, and we'll come back to that in a second. A transversal is a line that crosses at least 2 other lines. So if you've got 2 lines and the third line crosses those 2 lines, it's called a transversal. You can see that many angles are the same as in this example. So look at the look at the example. If you need to pause it for a second, pause it, or if you need to write this down, but stop writing for a second and just look at these numbers. I mean, you got 118, you get another 118, you get another 118, you get another 118. You had parallel lines and they were crossed by this third line. 4 of the angles were 118 degrees. The other 4 angles were all 62 degrees. So you could see that when you cross 2 parallel lines with a transversal, you're going to get a lot of angles that are the same because of the parallel lines. But guess what the 2 add up to that are not the same? They will always add up to 180. Always be supplementary to each other. So you kind of see that 62 and 118, 62 and 118, they're always going to add up to 180 here. Now these angles have special names. You've got to know the names. I mean, it's because that's when we list them, or when we say something, or I say here's two certain kind of angles, you just need to know where they are. So what I need you to do is look at this diagram on this website, because it kind of lets you play with it a little bit and you can kind of see it. The pairs of angles are down here. Okay, now watch closely. Your transversal. I'm going to click on transversal, and you should probably do the same thing. The transversal will highlight. See the highlighted right there? That's the transversal. Parallel lines, if I click those will show, it'll show me what they are. These are the parallel lines right here. This one and this one. Vertical angles, there are quite a few of them, so watch them. Okay, A and D are vertical. B and C are vertical. E and H are vertical. F and G are vertical. All those are vertical angles. You could click on these, more times it'll keep showing them to you. There's the vertical angles again. Okay, we have another special kind called corresponding. Corresponding, you might want to write yourself a little note, means in the same position. So next to it on your thing down here, you might want to write yourself a small little note here. Same position. And you could put that right next to corresponding. That's what corresponding angles are. So watch where they are. Okay, when I click on corresponding, look at where they are. A and E are both in the upper left corner. B and F are both in the upper right. C and G are in the lower left. And D and H are in the lower right corner of their little group of 4. So those are called corresponding. Angles in the same position. AE, BF, CG, DF. They're in the same exact spot in the little group. Those are called corresponding. Alternate interior. They're just what they sound like. They alternate and they're inside. So watch where they are. CF, alternate inside. DE, alternate inside. They're always inside the lines and they alternate sides. Okay, and an alternate exterior, just what it sounds like. They alternate and they're outside. Exterior means outside. So they alternate. AH, alternate and they're outside. BG, they alternate and they're outside. All of these are congruent to each other. All of those kinds that we just saw right in here, from vertical angles all the way down to alternate exterior, those are all congruent to each other. Okay, these are all congruent. The only ones that are not congruent are the last ones. These last ones, called consecutive interior, are supplementary. They're going to add up to 180 degrees. And they also have a special name called consecutive interior. And it's just what it sounds like. It's on the same side and it's inside. So consecutive interior, C and E add up to 180. D and F add up to 180. Those are always going to add up to 180. Basically, whenever you have a small angle with a big angle, it's going to add up to 180 with parallel lines. So you kind of see here, well, we have this for later. So there was a little chart. I would play with it a little bit. Get used to where they are. Click vertical, see where the vertical is. Click corresponding, see where the corresponding is. Just play with it a little so you get used to these names. I would do that. All right, moving on for you guys. Transversals is a line that crosses 2 lines. Here's a transversal that crosses 2 lines. Here's a transversal that crosses 2 parallel lines. Here's a transversal that crosses 3 lines. It just has to cross 2 or more to be a transversal. You can't just be crossing one line. So that was transversal. Okay, you can always pause it. Two lines that are parallel to the same line. If two lines are both parallel to the same line, then they are parallel to each other. Okay, lines A and C down here. So I know you want to write this down, so pause it, write it down, and then turn it back on. Lines A and C down here are parallel to line B. So A is parallel to B, and C is also parallel to B. If they're both parallel to B, then they have to be parallel to each other. A and C are also parallel. So if you see like A is parallel to B and C is also parallel to B, then those two lines have to be parallel to each other. If B is parallel to A and C is also parallel to A, then B and C would have to be parallel to each other. So line A is parallel to line B. Line B is parallel to line C. Since B is common, then A has to be parallel to C. Those two have to be parallel to each other. Again, pause it so you can write that down, and then I'll move on to keep the video a little shorter length. Perpendicular to the same line. If two lines are perpendicular to the same line, if they're perpendicular to the same line, then they're parallel to each other. Okay, watch this example right here. Pause it and write that down. And then when you start it back up, do this example. If you look at this example, it's an example of a rectangle. Okay, so you have line AB is perpendicular to BC right here with the box. You have line DC is also perpendicular to BC because that's got the box. So if this line and this line is both perpendicular to this end, then these two have to be parallel to each other. So they're both perpendicular to BC, therefore they have to be parallel to each other. Only way they could both be making 90 degrees is if they're both going the same direction, so they have to be parallel. So AB is perpendicular to BC, DC is perpendicular to BC, and notice that BC is in common, so that means that AB and DC have to be parallel to each other. And you can write that down. It just says AB and DC are both perpendicular to BC. This line and this line are perpendicular to the end line. Since they're both going the same direction, making it a 90-degree angle, they have to be parallel to each other. And that's the end of your notes. Now I just want to show you a little extra credit that you could possibly get. Here's a puzzle for you. So it says you have 3 bags, each containing 2 marbles. Bag A contains 2 white, bag B contains 2 black, bag C contains 1 white and 1 black. You pick a random bag and you take out 1 marble. It is a white marble. What is the probability that the remaining marble from the same bag is also white? You can figure that out, put that answer on my desk tomorrow, and you can get some extra credit. All right, we'll see you guys tomorrow.